welcome to this tutorial about securing APIs. I currently have a post API, like a blog post or any kind of post, where people can create, update, edit, and delete and view posts. But right now, if I were to deploy this app, anybody with an internet connection can do anything they want to the posts. So they can create posts, they can delete posts. It has no security. And so the goal of this is to secure it so that only people with the right permission can do certain actions on my API. But first, I wanted to fix a few things about this. First of all, it doesn't have a lot of error catching code. So if something goes wrong, it will fail silently and I won't be notified. And as we add security, it's nice to be able to know when things go wrong so we can fix the errors. Also, we want to make sure that we have the proper status codes that say that things do go wrong or the person using our API doesn't use it the right way. We want to send back the right HTTP status code so that they know what went wrong and know how to fix it. And third, if this app is going to grow a lot, I mean right now I only have one model posts, but as it gets bigger and bigger, it could be we could quickly get really disorganized. And Express doesn't have a set way where you put certain files, like a framework like Ruby on Rails is very opinionated on where files go. Express kind of is free for you to put files wherever you want. But with that, we better get organized to make sure our code just isn't spewed all over the place and it gets really hard to maintain. So we want to set up a little bit of organization. So first we're going to do those three things. We're going to catch all of our errors. We're going to make sure we're sending back the right HTTP status codes. And then we're going to set up a little bit of organization so this app can grow without becoming unmaintainable. Now the first place I might want to catch an error is if I have trouble connecting to my database. Without a database, my app isn't going to work. So if my Mongo connection doesn't work, I want to catch the error, print out an error message, and this will also print out the call stack and we'll exit. Now you also might be able to have the routes functions right in the main server file. This is index.js is my main server file, but it's nice to collect all of those into a single file, a routes file that I'm importing or requiring up here, and then I can use that routes and attach it to the /API endpoint. And then in the routes file, we can have all of our functions for our API. And this function right here is really good to do some logging to know that at least your server got a request. By putting this first in our routes file, without any first parameter, we just require a function. Up here, it'll log that a request came in, and then by calling next, we'll go ahead and route it to the next function that the API should be calling. Another really nice function to have is some sort of test, a test endpoint, just to check to make sure everything's up and working. And so this is /test API, and it will just return a message that it's working. Other things that we might want to do inside of this is catch any errors. So with promises, you can do this. So anytime you're using Mongoose, and I'm using Mongoose for my Mongoose to be able to interact with the database. So anytime we do a find or save or anything like that, we can chain it. It will give us a promise, and if it works, we could go ahead and send the stuff back. If it doesn't work, then we can catch the error and send it a function to run. And in this case, if our connection for some reason doesn't go through and we're not able to get a connection, then that's something wrong with our server. So that's a 500 status error. Now I'm going to put a link in the description of all the different status errors that you might want to send back based on what happened. But as you can see, 100 level status are just information, and those probably really won't be used by an API. 200 means everything worked. So if you're going to send a 200 status back, and by default you always send a 200 back, that means it was everything worked and was successful. 300 is any sort of redirection, meaning you moved an endpoint or the endpoint temporarily moved. 400 means that something is wrong with the request, or in this case, it says the client didn't do something right. And 500 means something is wrong with us. Like I said, 500 status error. The server had problems communicating with the database. That's not the client's fault, that's the server's fault. So it's just saying 500, something's wrong with me. Usually if you're consuming an API and you get a 500 back, you might want to wait an hour or two, see if the servers just needs to be configured, and hopefully they're working on fixing it, and then their request will start working again. Whereas if you get a 400 error message back, that means you did something wrong and you better look at your code or your request and figure out why it didn't work. So I'm going to put a link to this in the description below so you can refer to it. So whenever you query the database through Mongo's, whatever function you can use, you can add your promise on success and then catch any errors afterwards. There's also this syntax where you can pass it a function that will, and that function takes an error parameter that you can check to see if something went wrong. So there is more than one way to do this. But for instance, here is another example of creating a post. We're making sure that there's both the title and the content. And if not, we're returning a 400 error. And that means that they don't have their parameters right. Or that could include an error that they don't have their parameters right. So that's why we're setting status 400. And then we send back some JSON with an error message that they can read. So you might want to go through all of your code and make sure that you're catching any errors and sending back the appropriate status code so the person using your API knows what went wrong. Now let's work a little bit on our organization. So right now I only have one model that I'm dealing with, the post model, and all of the code that deals with posts is inside of this routes file. Now if I start adding more models and adding more and more endpoints inside of this file, then we'll have one really big file with all of our API implemented in that file. So thinking ahead, if we're going to have more than one model, we probably want to separate the routes out into different files, one for each model. So we probably want to create a new folder in here and maybe call it the routes folder, and take our routes file and put it inside of the routes folder. And Visual Studio Code will update the imports for you automatically. I'm not going to have it do that, so I can show you what else you might need to update now. And another thing that we might want to do is rename this to Posts.js. So it's named appropriately, so we know that all the code that deals with posts is inside of this file. Going back to our index file, now of course this import isn't going to work anymore. It's now in the routes folder and it's called posts. And we might want to call this posts as well and fix it down here. Now once you make a change like that, it's good to test out your API and make sure everything's working. And as you can see, I sent this and it's not working. So by the way, I'm running my server using NodeMon, so when I make save my files, it automatically restarts the server. But if the server detects something's wrong, the restart fails. So to see that, we can pull up my app running in a terminal window, and we can see as we look through this call stack that we can't find the post models up here. So inside of my routes file, of course, this needs to update, and we can probably just take off that period and then find the posts, and let's see if that works. And it still can't find that, so we want to go maybe up one folder, then to the models, and then the posts. Let's see if that works. And yet now our server is started, and by sending our using Postman to send a API request to our test API, we see that it's all working. So that's nice that we have this little function here And we can also just go to posts to see all of our posts working as well. Now you can see that I've already my app already had the post model inside a folder called models, so that that's kind of set up the same way as our routes already. But if you don't have that, you might want to update your app to put that in the appropriate spot. One thing that might get a little tedious is requiring all of the different route files inside of our app or all of our model files. So one way to make that easier is to create an index.js file inside of these folders, and inside of that we just require each individual file. So we put all of the new routes files that we create, we just add one line in here, and this exports a JavaScript object. So now in our main server file, instead of requiring the post routes and then all of the other routes that we're going to create, we can just require the folder. And since we named this index.js, it will refer to that and get that JavaScript object recreated in this file here. And so now when we connect it up with the new route, we can just do the routes.posts. And that allows us to add more and more routes files without a lot of too much extra effort of requiring things. Now I've done the same thing for my models. Inside of the post model at the end, you see that I export the model that I created, and then in index.js I require the posts. Now that's going to require me to update the post.js file, where instead of requiring models post, which we can do, we can just require the models folder, and we can call that our models, and then we can create a new variable called posts, post that equals the models.post. Now make sure you stay consistent with your names. Notice this is a capital P. Models are usually capitalized, so capital P in the name of the file right there. And in my index.js, notice I capitalize that P and capitalize that for the name of the file. And testing this out once more in Postman, we see that our API is still working after we've updated all of that. Another good idea to update is to specify your schema a little bit better. You could just replace from this here to here with just string, but by adding in another layer of brackets here, you can say that you want this string to be required. That way Mongoose will help us out making sure that all of our data stays consistent. To continue on with this tutorial, there's a little bit of required reading, and I'll include the link to this in the description below. But we need to do user authentication and authorization. So just briefly, user authentication is verifying that the user is who they say they are. And then authorization, now that we know who the user is does this user have permission to do what he's trying to do? So that authentication is verifying that the user is who they say they are. Authorization is, does this user have permission to do something? Now, authentication is usually done with a password. And there are other ways of doing it, like logging in with Facebook or other social apps that you can use to verify that a user is who they say they are. And authorization, you're going to have to write that in your own code. So I'll let you read through this. I use this as a little bit of a guide on how to do authentication. One thing that you want to pay attention to is this JSON web token. Basically, we're going to use a little bit of cryptography to sign a web token, and we'll give that to the users that log in, and then they can give us that token back, and we can verify that they haven't changed it, and that will let us know who they are, and then we can determine if they have the authority to perform the action they're trying to perform. So this is what a typical user will do, is they'll make a request to sign up, sending up their email and a password that they want. We'll go ahead and save that user in the database and return that to them. Then they can send another request verifying their password, and then we'll create a token that they can store on their end. So they'll receive the token. Now, if they're using a web application to do this, then they'll probably store the token in their cookies. If they're using a mobile application, they'll store it in their keychain or some secure storage where hopefully hackers cannot get their token, because the token will identify them. Then from then on out, whatever they want to do, they'll pass that token to us. We'll verify that the token hasn't been messed with or changed through cryptography. And if it hasn't, then we'll know who the user is. We'll determine if they can do what they're trying to do. And if they can, we'll go ahead and do that action and send them back a response. But make sure you read through this full article. You don't have to really pay attention to the code, but read through the full article so you can understand exactly what we're going to do. So the next step will be able to create a Mongoose model for users. And for me, I'm just going to store an email and a password. Now, we're not going to store their password in plain text. That would be really bad. If someone got a hold of my database, they would have everyone's password. So we are going to encrypt it using bcrypt, which will also salt the password, which protects against rainbow attacks. But anyways, this is my user model, and then we'll just export that down here so that other files can use our user model. And with part of that, we're also going to want to add this into our index.js file so that they can just import all of the models in one file in one required line. And now index.js will export both of our models. Now next we'll want to run npm install and install some of the libraries we're going to use. Now instead of building everything from scratch, we're going to use Passport, which is a library that will help us do the authentication. And we're going to use Passport.js web tokens, and Passport local is the strategy. And a local strategy means we're going to use a local email and password. You can use other strategies like login through Facebook or other applications. Now, we're also bcrypt is going to encrypt our passwords before we save them in the database. And JSON web tokens, hopefully you read about that. That's how we're going to that's what we're going to give the user as a tokens to identify them after they've logged in. So go ahead and run this npm install command to get your new libraries installed. Now if you're running your node server from a Docker image or a container, you need to run npm install on the container so that you can install the libraries on that container. So to get to the container, you can run docker compose, assuming you're using docker compose exec, and then we'll run this on the web container that's running our node server, and sh gives us an interactive shell. And now we can just do npm install, and hopefully that will install all of the things that we need to install on the container as well. Now you'll probably want to restart your servers or make sure they did restart with Notepad after you've installed all the libraries. Now back in my user model file, I'm going to add a pre-save hook into the user model. So this function will get called before save gets called. So if anybody tries to save a user, what we're going to do is see if they've set a new password or if it's a brand new object, hash up their password or encrypt it so that it won't be saved in plain text. And then down here we'll add a compare password where they can pass in a password guess and a function, and I will use bcrypt to compare the password to their hash, and if there's some error then I can return that error. Or I can call their callback. If there isn't an error, then I'll take the is match, which will be true or false, and pass it to them. So they can now we have a function that can compare their password to the original password that got hashed up. Now just make sure that you require that bcrypt library in order to get access to the bcrypt functions. Next, I'm going to create a config folder where we can put in some configuration, and the main thing that we need to configure is Passport. I'm going to create a Passport.js file that will have the Passport configuration, and in this we'll require the Passport.json web token as a strategy, and also the ability to extract a JSON web token. Now we're also going to require the user model, and we don't need that. And here we're also going to set our secret. Now this should probably be a long string of random characters, but this is going to be used to sign our JSON web token. If people know this secret, then they'll be able to sign their own JSON web tokens and fool us. So make sure that this doesn't get out to anybody. In fact, you probably don't want to put it in your code and check it into your code repository. You probably want to include it another way. But I'm just going to put something simple here for the this tutorial. And if you're not going to release your app or deploy it, then of course you can use whatever you want and it won't really cause any problems. But if you do deploy your app, make sure that you do some research on how to get your secrets out of your code base. That way people can't find them and then use it to attack your site. So what we're going to do is configure Passport here. So we're going to export this function. We have some options. So one option is JWT from request. We're going to extract the JWT. That's this that we imported. And we're going to use the JWT strategy. And then we're going to set our secret to our secret up here. Next, we're going to tell Passport to use the JWT strategy, and the function in here is what's going to grab our web token. This is after they've signed in, they have their web token. They can give us the web token, and we're going to verify that it has been signed, and then from that web token, we can be able to pull out their user ID from the model. And if anything, any errors happen, then we can report the errors. If we're able to pull out that user out of the database, then we can give the user back to them. And if not, then we'll just return false, saying this token isn't valid. So that will, now when all the requests go through this flow, they'll be able to see, and somebody provided the right JWT token, so we'll be able to find the user in that token. So now that we've configured Passport, let's create a way for somebody to sign up and log in. So I'm going to add a new routes file called auth.js. Now this will just have authentication endpoints, and this will not be protected, so we're going to let anybody who wants to come and sign up and try to log in. So we're requiring Express and Passport. We need JSON Web Token and the user models. And so we're going to create a new router, and so when they create a post request to the sign up right here, we'll make sure that there's an email and a password, and if not, we'll tell them, send them back an error message. If there are, we'll go ahead and create a new user and try to save him. And this is another way to catch errors. We could call the save function, pass it a function, and it will let us know if there's an error. If there is, we can, in this case, because they might use an email that's already registered, we'll just assume that the email already exists. And if the save is successful, we'll give them back a new user object with a message saying that the user was created. So now they can sign up, and this is something that they can log in, and we're going to make sure that there's an email, and we're going to find them in the database. And if we didn't find them, we're going to say, hey, there's no user found. If we did find them, we're going to compare their password. We're going to call that compare password function that we wrote in our users models, and pass it this callback function. If there's a match, we'll go ahead and create this object. This is going to be the token, and we're going to use JWT to sign it using our secret. And then we'll send the request back to them. And if not, then we'll say there's a wrong password. Now, in order for this config secret to be public and be accessible from both this routes auth file and our passport setup, I decided to create a new file called config.js. And in there, we're just going to export the node auth secret or our secret key. And then in Passport.js, we'll require the config file and set the secret to that. And then in our auth file as well, we'll require that config file, and we'll require the config file, and then down here we can pull out the secret. Now that we've added another routes file into our routes folder, we'll add it into the index.js as another export. And then since we're requiring the index.js file, that'll include the auth, and we'll add this new routes into our app. This is in the main index, our server file. We added in this new routes. And now that we have that, we can go ahead and test the sign up and login functions. Now, as I was starting my server, I noticed that I was having this problem, and that is because my node container happened to pick up bcrypt that was installed on my local machine, which happens to be a Mac, and my node container is running Linux. So we need to make sure that the node container gets its own copy of bcrypt. And so in a new shell, we can run the docker compose exec command, and we want to run this on the web, and we'll get a shell. And to fix it, just type npm install bcrypt. And we can exit out of that shell, and then we can make sure that we restart our server. So make sure you Control C to stop that, and then docker compose up to get the server started again. So if you noticed, I mounted this auth at /API/auth, so /API/auth/signup with the endpoint to be able to sign up a new user. So let's go ahead and try that. So in Postman, I put in that URL. I made sure that I have a body that is raw and that it's JSON format, and I provide an email and a password. And then sending it will give us this response, and you can see that our password is all hashed up. It no longer just says password, and we got George, and this is his ID. So that part worked. Now let's go ahead and try to sign George in. So you can see that the login endpoint right here is what we want to call to be able to sign a user in. Now, just as a test, I'm going to go ahead and try to create George one more time. So by clicking send, you notice that I get a 400 bad request back, and it's telling me the email already exists. So that's good. No user, two users with the same email can sign up. So that works. Now let's go ahead and try to log George in. So we'll go to the login, and we'll pass his email and his same password again, and we'll click send. And down here we tell success is true, and we're given back this JWT or JSON Web token. Now we'll want to use this JSON Web Token whenever we want to call something that is secure. And we're going to do it by passing it in the HTTP headers. So what we could do is click over here on the headers and click this authorization, or add a new key called authorization, and then just copy and paste your token that you received down below in the value field. And from then on out, as long as you check this checkbox, you'll send the token you'll send the token with you, and if you notice, the token has your ID inside of it, and it's been signed, so you can't change it. So now whenever you send another request along with this token, your Express server can not only verify that you have permission to do it, but it knows who you are. And just to show you what the token has in it is it has your ID and your email, and then it just signs it, and that's why it looks like a big long random string that actually that doesn't really hide this. It's just encrypting or encoding your data in a different way, and there are tools that allow you to read the tokens. But the only thing is that you can't change it. If you change the token, then the signature won't match, and it knows that, and Passport will know that you messed up or you tried to change the token, and it will reject it. Okay, now that we're able to give users a token to be able to access secure routes, or routes that we don't want just everybody sending requests to, now we can, in our index.js file, our main server file, we can require the passport here and initialize it. And then down below, we'll say we're going to want to do passport authentication with JWT. The session's false because on every request, they're going to have to send that JWT token. And we're just putting it on the posts routes. That's the routes that I had before. We're not putting it on the authentication routes. So these won't have any security on them at all. That allows people to sign up and log in and get their tokens without having a token already. And these routes will have a token. So what you might want to do is, if you want users to be able to edit their email or change their password and other stuff, you might want to have another mount another routes file, create another routes file that has all the other things that you might want to do to a user, and make sure that they have their JWT token first. So you would mount that routes file the same way you mount the posts routes file. But I'm not going to do that in this video. Now this is our post file, and now I'm going to have both users and posts. So I'm requiring all of my models, and then to make sure I don't have to rewrite my code, I'm just going to have this post variable here. But now on my test API, I'm going to pass back the user that is logged in or that sent the token to us, and this will be a good test, so we'll be able to see the user. So the way that Passport works is when we configured Passport right here, it was able to find that user, and we were able to return it to him, and he attached the user to our request. And so we can get the user out through the request. And that's what middleware does. Before the request gets to us, Passport does its thing verifying the token. And if the token is valid, he'll find the user, attach it to our request, and that way we can see the user. So let's go ahead and test this test API endpoint out. So just to make sure this works, you probably have to require the Passport library as well, or else this call will fail. But with that in, our servers should start up just fine. All right, so now we're going to make a GET request to that API, and we're going to add in our headers, the authorization token that we got back from logging in. And when we click send, we can see that we got it working, and we see all of the user that it is. Notice it knows that this is George because it was able to extract his ID from this JSON Web Token that's been signed, and then look him up in the database, and now we have his email and even his password. So that part is all working. Another test is, what if he doesn't pass this authorization string on? We can click send again, and notice it says unauthorized. And that's a 401 unauthorized error because they didn't provide the authentication. Now, if we authorize it, and let's go ahead and change this JSON Web Token by 1 character, and click send again, and we still get that unauthorized. So you see that they can't mess with the token because it knows that the token has been changed. But if we get the right token, then we get the authorization, and we even know who sent it. Now I could stop the tutorial right there, but I did want to go a little bit further. Now that we know who this user is, maybe we want our posts to have an author related to whoever created the post, so we can automatically attach authors to our posts. Now once we start doing relationships, we're using a different kind of database than a SQL database that you might be used to. A MongoDB is kind of referred to as a NoSQL database, and also they don't really have relationships in the way that we have before. So there is quite a bit of required reading, and I'm going to include a link to this in the notes as well, so that you can figure out what kind of relationships you have. And there's many, this all talks about one-to-many relationships, but there's a lot of different kinds of one-to-many relationships, and how are we going to look up our information? There's just more stuff we have to think about when we have relationships using Mongo. So make sure you read through that. I'm just going to do a simple one-to-many relationship between users and posts. So one user can create lots of posts, and each post will have his author. So in my post model, I'm adding another author field whose type is going to be an object ID and is going to reference the user model. So that's how we connect these up. This is kind of like a foreign key in a SQL database. And that's what we're going to do. But there are other ways that we can relate these two objects, posts and users, together. Now inside of the routes post file, where we have all of our API code, when we go to create a new post, we can get the users out of the request and attach him as the author of the new post. So now the author will automatically be filled in with whoever made the post request, because this will only get called if they sent a correct authorization token or JWT token to be able to identify themselves. And then when we go to find just one post, what we can do through that relationship is we can populate the author, and that will give the author information back in the request of who made this post. Now we could do it also on the endpoint that gets all posts out, and we can get all the authors, make one more request to the database, but maybe we don't want that information when we get all the posts, but we want to add some more information when we get a single post. So you can see I have one post that I already created to test this, but let's go ahead and create another post. So we're going to make a post request to here. We're going to make sure we include a body that's a raw, and at this time we want a title, and let's do test post, and then we want content. And let's go ahead and send this, and we get that our content has created and it has automatically attached our user ID to it. So now we can go ahead and get this post out, a single post. So we'll pass in the ID and make sure we do a GET request so we don't need to send a body anymore. And by the way, all of these are being done by sending that authorization token as we did before. So we'll send that request, and now we can see that the author really is George, and we have all of his information. Now of course we probably wouldn't want to send this password hash back to give hackers an easy attempt to try to crack this password, because this contains the salt that Bcrypt is using. So we probably wouldn't want to include that in our response back, but we can include maybe the email or the name or some other information about the user. So to get rid of the email address, this populate function is basically when we get a post back, we tell it to go ahead and query the database again to get all the author information, but we're only going to ask for his email in this case. So that will limit the password from being put into the hash. So when we run that, When we run, and on Postman, we see that we just get his email and we don't get his password. And so that's all we'll do for this tutorial.